Water. Earth. Fire. Air. A long time ago, both sides of the equation lived in harmony. Then everything changed when the Fire Nation applied heat. Only LeChatelier, master of all four elements, could stop them. But when the world needed him most, he vanished. 100 years passed, and my brother and I discovered a new avatar, a chemist named Shriram. Yet although his chemistry skills are great, he has a lot to learn before he's ready to save anyone. But I believe Shriram can bring balance to the reaction.
The first thing that you need to know is that all reactions are slightly reversible under the right conditions. From your past laboratory experiences, you may have thought that reactions only progress in one direction. However, that is only because those reactions heavily favor the forward reaction. In reality, the reverse reaction is also occurring, but the products are favored over the reactants. Eventually, the forward and reverse rates of reaction will equal each other, and the concentration of products and reactants will stop changing. This is known as equilibrium.
When a system is shifted from its equilibrium, we can use LeChatelier's principle to understand its effects and how to reduce this change. LeChatelier's principle states that if a change is imposed on a system at equilibrium, the position of the equilibrium will shift in a direction that tends to reduce the change. Before the Fire Nation applied heat, the equilibrium position was at harmony between the two sides of the reaction. However, according to LeChatelier's principle, this stress caused the equilibrium position to change and move towards one side. A shift in equilibrium to the right means that the reactants will be consumed to produce more products, and vice versa for a shift in equilibrium to the left. LeChatelier's principle will allow us to restore balance to the reaction.
There are three main ways to change the equilibrium position of a reaction: changing the concentration of reactants or products, changing pressure, and applying or removing heat. Simply put, LeChatelier's principle states that the system will counteract any change applied. So if the concentration of a reactant is increased, the system shifts towards the products to counteract this change, because by shifting to the products, the reactants will decrease. Imagine a seesaw that is at equilibrium. If a stress is applied to one side by putting more weight on the right side, the seesaw will become unbalanced. In order for it to become balanced again, some of the weight has to be moved to the left. As a result, increasing the concentration of one side will cause the equilibrium to shift to the other side, whereas decreasing the concentration will cause the equilibrium to shift to that same side.
A change in pressure will only have an effect if there are gaseous products and reactants, although not all the products and reactants have to be in the gaseous phase. In a change in pressure, the reaction will attempt to shift in a direction that preserves the pressure of the system. You will need to compare the moles of gaseous reactants to the moles of gaseous products. If the pressure is decreased, then the equilibrium will shift to the side with more moles of gas. And if the pressure is increased, the equilibrium will shift to the side with less moles of gas. If the moles of gas are equal on both sides, then a change in pressure will have no effect on the equilibrium. A change in pressure can be created by changing the size of the container or adding an inert gas to the system. If the size of the container is increased, pressure decreases and the system shifts towards the side with more moles of gas to maintain the pressure. If the size of the container is decreased, the volume will increase and the system will shift to the side with less moles of gas to maintain the pressure. If an inert gas is added to the system, the total pressure will change, but the partial pressures of the reactants and products will not change. This means that there will be no change in equilibrium.
The third way to shift equilibrium is with temperature changes. Depending on whether the reaction is exothermic or endothermic, temperature can function as either a reactant or a product. Exothermic reactions release energy, therefore heat can be thought of as a product. When you add heat to an exothermic reaction, the system will shift to the left because it is as if you are adding a product to the reaction. If you add heat to an endothermic reaction, where the heat can be thought of as a reactant, the system will shift towards the products.
It should also be noted that the addition of a catalyst will not cause the equilibrium to shift either. A catalyst lowers the activation energy for both the forward and the reverse reactions. In other words, the rate of both reactions increase equally, meaning that the equilibrium has not changed. So why is LeChatelier's principle important? Well, LeChatelier's principle has a lot of practical importance in the world of making industrial chemicals. In the making of these chemicals, reactions are carried out on an enormous scale, and chemists want to increase the yield as much as possible. They make use of LeChatelier's principle in order to do so and maximize the efficiency of their reactions.
One very common example is the reaction between nitrogen gas and hydrogen gas to form ammonia, also known as the Haber process. Ammonia is often used in fertilizers and other pharmaceutical drugs, along with several household cleaning agents, and is very high in demand. Chemists are able to use LeChatelier's process to increase the amount of ammonia being produced through several different methods. First, gaseous ammonia is removed as it's being produced, with the unreacted hydrogen-nitrogen gas remaining in the reaction vessel. The removal of a product will cause the equilibrium to shift to the right in order to compensate for that change, resulting in more ammonia being produced. Since the reaction is exothermic, reducing the temperature could also cause the equilibrium to shift to the right, but since the catalysts are only effective at a certain temperature range, that specific change is not used. Since there are 2 moles of gaseous products compared to 4 moles of gaseous reactants, the reaction is conducted at very high pressures, once again to cause equilibrium to shift to the right.
Now armed with his newfound knowledge, the Avatar Sriram is ready to take on the Fire Nation and restore balance to the equation. So depending on whether the equation is exothermic or endothermic, when the Fire Nation applied heat to the system, it shifted towards either the right or left, and the reaction was no longer in harmony. Now he must bring peace using LeChatelier's principle and restore the old balance.
So should I look at the camera?
Yeah.
No, stop smiling.
Just throw the water.
I thought we were practicing.